Hey guys, how are you? Today is Tuesday, December the 15th. We are just moving right along December and we are almost to break. Just gotta make it to Friday, right? Well, it is our 11th day of Number Corner for December. And I have right here, you'll see today's calendar marker because we're going to talk about that really quickly. And then we're going to talk about some of the strategies that we've been using for our calendar collector this month, okay? So today is the 15th. Let's figure out how many sides our shape has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. 12 sides. So I'll add that. And then I just want to point out that we counted the number of sides and each side only has a side length of 1. And so really, our perimeter is also going to be 12. I could recount it, but I recognize that. Unlike yesterday where we had a side length that had 2 here and 2 here, or 3 here, 2, 2, 1, 1, 1. This one had 1 all around. So since we counted the number of sides, it also tells us the perimeter. So our area is still 5 square units because a pentamino only uses 5 squares. Let's figure out line of symmetry. How many lines of symmetry do you see? Remember, line of symmetry, I could fold it and it would be exact same on both sides. It's like a mirrored image. How many do you see? Was your first thought 2? I thought 2 as well because you could fold it down here and then right here as well. There are actually 4 because I could fold it vertically, horizontally, or I could fold it diagonally both ways. So we actually have 4 lines of symmetry. How about parallel sides? We actually have 12 of those also because these 2 sides are parallel, these are parallel, these are parallel, these are parallel, these 2 sides are parallel, these 2, like the parallel sides, each side has a parallel side to it because of the way that this shape is constructed. Means I have 12 total sides that are parallel. And perpendicular, I have 12 as well because perpendicular just is the corner. It says intersecting at a right angle. So here's a corner. We have 12 of those corners in this shape. Now, let's think about our race, or to 2,000 if you will. And we know that we've already surpassed 2,000. Yesterday when we played, we were able to get to the number 3,024. So, how far away from 2,000 are we? Are you thinking 1,024? I sure hope you are because 2,000 plus 1,024 is going to give me 3,024. So let's roll for today and let's see. I'm actually kind of hoping we get less so that we're not so far over 2,000. But let's see what we get. Let's toss all these numbers. Oh, we got more again. And we got some numbers here that are really going to put us way over our 2,000 mark. Before we solve to figure out what number we're going to end up with, let's fill in our chart. Let's create our number, and then let's talk about a strategy that we can use but really haven't used yet this month, or at least we haven't talked about it to solve this equation. So we got a 1, 6, and a 9. And we're playing for more. 1, 6, 9. We are playing for more. So what number should we create? And really, we could create any number we want since we're well over 2,000. But just to keep it consistent with what we've been doing, we are going to make the number 961. We want to make the biggest number possible. So There are a couple different strategies that we could use to solve this problem. Let's talk about some of the strategies that we have used already for addition. Somebody name a strategy. Great. Name another strategy. Right. If you were thinking, I'm not really sure of a strategy that I use, let's label some of them. You can jump to a friendly number. So that's like if you have the number 96, you're going to jump to 100 because that's a really friendly number. Or 73, you might jump to 80 because that's a friendly number. Or you can jump by a friendly number. That means I'm going to jump by 10. So I can add my tens, or I can count by hundreds, which is another way of saying you can use place value. Remember when we chunked a number? Using, kind of thought about it like the expanded form. Has anyone used the standard algorithm to solve any of these problems? Don't forget, you can use the standard algorithm. And we made a connection to the standard algorithm with our video when we had our money and we had to do regrouping and all that. And then I connected it at the end of the video, which was one of our longer videos this month. But we got to the standard algorithm. So we're going to do that today. Let's go. Give me a second while I pull up a whiteboard. All right, so here's my whiteboard. We know that we have the number 961, I believe is what it is, and we are adding that to 3024. So I'm going to write that out. We have 3024 plus 961, and that is going to give us our result. So just as a quick reminder of some of those strategies that I was talking about earlier. If you were to use a number line, which you could, or maybe you're thinking about it in your head, and when you're thinking about it, I'm just going to represent that thinking on a number line. So if I start at the number 3024, then I'm going to jump by a friendly number, okay? So I could jump by 100. So that'll be 3,124, 3,224, 3,324, 3,424. I could do that. Probably not the most efficient strategy to use for this problem because the numbers are so big. So maybe I use my knowledge of place value. Remember chunking a number. And first I add 900. So I have 900. And maybe I should have made a bigger hop for 900, but it's okay. Actually, it's not okay. Let me fix that. We want to be as proportionate as possible. So I take a jump of 900 and I had 0 so I know that now I have 3,924. This is me using my knowledge of place value. Then I'm going to jump 60, which is fairly easy because I know 60 plus the 20 that I already have is going to give me 80. So I now have 3,984. And then I can add my 1, which is going to be 3,985. Okay? If you solved this problem already, hopefully you got that. If you didn't get that, you might want to check your work. Okay? So that's one of the strategies. And it's probably out of those three, whether I'm jumping to a friendly number and then jumping the rest of the distance, or I'm jumping by a friendly number that didn't really work for this problem, I can chunk. But guess what else I can do? The standard algorithm. So that might even be the best thing to use for this problem. Plus 961, and I'm going to try to line it up as best as I can. All right, so here's our problem. Let's think about this. What is 4 plus 1? 5, which I didn't create my number here, but the answer is 3,985. That is my answer. Okay. Now I have 2 tens plus 6 tens, 8 tens, 9 hundreds plus 0 hundreds, still 9. Notice my language when I'm talking about using the standard algorithm. I'm not saying 4 plus 1, 2 plus 6, 0 plus 9. That 2 is really not a 2. It's a 20, or it's 2 tens. And that's sometimes where we get into trouble when we're using the standard algorithm, but we're not thinking of place value at the same time. Then I have 3,000s plus nothing. It's still 3,000, and my answer I got is the same thing I got by using the number line. So please don't forget the standard algorithm. Let's add that here. 3,985. That's what we got, right? Yes, it is. Perfect. Now let's talk subtraction strategies. What are some subtraction strategies that we used when we got less? Which it seems like this month they just wanted to keep adding and adding and adding. So we didn't do a lot of subtraction, but when we did, what strategies did we use? Right. We actually still could jump to a friendly number. We still could do that. If we were taking 874 and we had 874 and we were taking 126 away, we still could jump to a friendly number. That's one thing that we could have done. What else did we do? Let's look back at some of our numbers, maybe some of our notes. Mr. Mill only took a couple notes this. Oh, look. Took away the smaller number in chunks. Another strategy, which I'm going to call using place value chunks. Okay. Does anybody remember Mr. Mel talking about this constant difference? Which is when kind of you're adding up, you're finding the distance between two numbers. So essentially you're going from the smaller number to the bigger number. And you could do that by adding up, starting from the smaller number. You could also find the constant difference by going backwards to the smaller number. So that's another option. Guess what else you could do? The standard algorithm. So we're gonna do subtraction using the standard algorithm with some of the numbers that we had from earlier. So let's take 1,384 and subtract 1,139. 1,384 minus 1,300. Well, actually, we subtracted 245. Minus 245. It's going to give us our answer. So let me show you some of those strategies really quickly, and then I'll do the standard algorithm. So here's what I meant. On this number line, I should start at 1,384, and I could go backwards. Well, since I'm subtracting, I definitely should go backwards. And I can go backwards by subtracting using our knowledge of place value. So we could take away 200 and then 40 and then 5, which 200 would be 1,364. And then we would take away our 40. Oh wait, did Ms. Trammell do that right? No, she did not. Good thing I caught myself. If I took 200 away, I actually end up with 1,184. And then I could take away my 40, which would be 64. And then I could take away my 5. Well, my 5 I'd have to cross over, so I end up having to regroup using my knowledge of regrouping. That's one way. What you probably would not have wanted to do is start at the smaller number and count up to the bigger number, because they're so far apart and you would have been adding so many different numbers. So the best method for this one would have been to take away the smaller number using chunks, using our knowledge of place value, or you can do the standard algorithm. So let me just show you that really quickly, and then we will be done. Minus 245. Right, we always start in the ones place. So if I try to take 5 away from 1, I can't do it. So think about me trying to take $5 away from this amount. Well, I know I have a $10 bill, so I can take one of those dollar bills and give myself 10 ones. Or if I'm taking away dimes, like we were talking about before, I can take one away from here, 1 10 away, split it up so that I have 10 plus the 2 that I already have. Now I can do my subtraction. 12 minus 5 is 7. 7 minus 4 is 3. 3 minus 2 is 1. And I still have this, which means we may have made a mistake, guys. Or maybe Miss Tramel's subtracting wrong. 12 minus 5. Minus 3. I should be 7. Oh, I know. I'm silly. I know exactly what I did wrong. I wrote 82 instead of 84. I was like, whoa, that's different than what I thought it was going to be. So that means we actually have 14 instead of 12. And 14 minus 5 is 9. Now we know we did it correct. Okay, so standard algorithm, you guys need to know how to use it, but if you don't, you still have other strategies to fall upon. Okay, you guys have a great rest of your Tuesday. I'll see you tomorrow for Number Corner. Bye-bye.